at 1, what's happening each minute? Are we gaining or losing each minute? And at 2 out at 1. We're going to gain 1 liter every minute, right? So if our volume starts out with 100 liters and we're gaining 1 each minute, then really we've got 100 plus 1t, right? That's our change, right? 1 per minute. If it went, let's say, in at 2 and out at 5, then it would be start with 100. In at 2 out of 5, I'd be losing 3 per minute. Okay? So it just depends on, the change of what's going on and how much you started with. So when we say volume at time t, if it goes in and out the same, it's just 100, the initial. But here, we're going to gain 1 per minute, right? So it's 100 plus t. So this is our equation, and it's going to be a linear equation because if I move, so this is dA by dt. So if I move this term across and make it plus 1 over 100 plus TA equals 40, you should be able to tell it that would be linear now, right? And our initial condition is A of 0 is 0 because at time 0, there is no grams of salt. So to solve this as a linear, this would be called our Q of t, and this would be our P of t. And then we could use our method of linear to solve it. Okay. Questions? All right, let's do it. So initially, the tank contains 2,000 liters of pure water. A valve is opened, allowing a brine solution containing, okay, so that's at the start, 0.1 kilograms of salt per liter to enter at 5 liters per minute. It's stirred constantly is another way to say it's going out at 5 liters per minute. I personally hate that terminology. I wish they'd just say out, but sometimes they do it like that. Determine the amount of salt T minutes after opening the tank. Okay. So at time 0, there's no salt, right? So Y of 0, 0. And then we have, that's a rate going in, and that's a rate going in, and that's the rate going out. And we know our units have to match. So if I let's say Y be the amount of salt in the tank, then we can say dy by dt is going to be 0.1 kilograms of salt per liter, entering at 5 liters per minute, which is grams per minute. And this is grams per minute. And we're going to let Y be in grams. So in minus, and then out is another 5 liters per minute times Y. So this is rate in, this is rate out, and this is the volume at any time t. So in this case, it's going in and out the same rate, so it's just always going to be a volume of 2,000. Okay? And the units are okay again because it's liters per minute and grams, and then the bottom is liters, so they cancel again. So if I write it a little bit easier for linear, 0.1 times 5, that's 0.5. That's going to stay on the right. This 5 over 2,000 is going to move across, and it's going to be plus, right? So dy by dt plus here 5 over 2,000 y equals 0.1 times 5 is 0.5. Now, because it's already a big pain, you may as well reduce this, right? So it's 1 over 400. So that's my P, and that's my Q, and it's a linear. So we would need to do our integrating factor. So integrating factor, just like always, e to the integral of p of t, which is just a constant, 1 over 400. So these are always kind of weird because you think, well, what is this? But, you know, the integral of a constant is just the constant times t. So it's just e to the 1 over 400 times t. And then we have our solution, just like always. V of ty is integral v of t q of t dt. So that's v of t. So go ahead and fill it in, what you would get here. So e to the 1 over 400 t y equals integral e to the 1 over 400 t, and then q of t is just a half, right? We just want to stick a half out in front. Okay, so what do you get when you integrate this? And go ahead and find your c, right? Remember, your initial condition was at time 0, there was no salt. So y of 0 is 0, in other words. Okay, let's see what you got here. So my integral, let's just write down the left side for a sec. Integral of e to the 1 over 400 t here. So we would have, it's like integral of e to the 2t is e to the 2t over 2. So it's just annoying. It's e to the 1 over 400 t divided by, right? If it was a 2, we'd divide by 2. So we have to divide by 1 over 400. And of course, if you forget your plus c, you're in trouble, just like always. So it's 1/2, and then if we divide by 1 over 400 here, it's like multiplying by the reciprocal, right? So we can take a half times 400, so that's really just 200. So it's e to the 1 over 400t, y is 200 e to the 1 over 400t, plus c. And let's sub in our 0, 0 point and find c. So e to the 0 times 0 equals 200 e to the 0 plus c. That's 1, but 1 times 0 is still 0. And that's 1, so that's 200 times 1 plus c. So c is negative 200. So if we put that into right here, we would get e to the 1 over 400 ty equals 200. E to the 1 over 400 t minus 200. So final answer, just divide everything by that e to the 1 over 400 t. Those are gone, those are gone. So y would be 200. You could leave it like this, but they'll probably write minus 200 e to the negative 1 over 400 t. So that's the equation to find the amount of salt at any point in time. You know, if they gave you t is so many minutes, then you could put it in. But, I mean, they'd have to make it pretty simple because you don't have a calculator on the exam, right? Okay, questions? So yeah, it looks like somebody messed up and didn't change the time of the session. So part 2 is at 10 a.m. I had to change it a while ago and I don't know why it didn't get updated. So my sincerest apologies for that. So I hope you guys can still come. I'm really sorry that someone screwed up. Yeah, so hopefully that's okay. Well, I mean, sometimes, Olivia, they'll make you do all of this, but sometimes they'll just say set it up. So yes, it's a level of difficulty if they're mean and they make you do it, but there is sometimes exams where they just say set it up, right? And then they're just looking for this equation before I started writing all over it and the initial condition, like y of 0 is 0, right? So, you know, it's just hard to know, right? From year to year, they don't always ask the same things. But, you know, they say, like, you have to know everything, right? So it's like the IV question, right? Sometimes they'll just say, you know, get the equation. It's like, well, that's a lot easier than going through what we'll have to go through tomorrow for IV questions because they're horrible, right? But yeah, the Bernoulli is probably the thing that they've made the hardest in the past. So let me see if I can find the one to show you guys. Now, last year, we're kind of mean with different things, right? So last year, this is kind of what the Python looks like. So I made up a whole bunch of questions just like the Python on the exams. But last year, their hardest question was this one. It was about a rare disease. And, you know, I know you don't have to know sensitivity and specificity, but you might want to practice that one, you know, or make a note of it for the final because it really caused a lot of issues. So they had a Bernoulli, which was pretty straightforward, right? Like their Bernoulli wasn't crazy by any means. But the year before that, when they had their Bernoulli question, so this one, see how it says, was this one a solve? Oh, this one was solve an IV question. So they had to do the whole thing. So that one was, oh no, look, it says, but do not solve. Yeah, so that's the one I was thinking of. So see how they give you everything? We're going to do this one tomorrow, this style. But, you know, they got lucky, right? It says, set it all up, but don't solve it. So you had to do like the first part, but you didn't have to finish it, which is a lot less work. But look at their Bernoulli that year. I mean, that's horrific, right? Because it's a product, so we knew we had to multiply it out. But what happened was a whole bunch of students multiplied it out wrong. So then you're in trouble because you know what they gave them? They gave them 0 to 6 because they're like, well, if you don't have the equation, it was horrible. Like the marking was really, really mean, in my opinion. So, yeah. And I think it was the year before. Yeah. So check out this Bernoulli. Again, you had to multiply it out. And if you made a mistake, then you're in trouble, right? So, yeah. So maybe if you want to do one of those, we can do one of those. Okay. All right. So I think we should call it a night for tonight. So I hope you learned a lot today, and I really hope you can make it at 10 a.m. I apologize for having to change the time, but I had a conflict. So I will hopefully see you all back tomorrow, okay? And hang on now if you have any questions for me, okay, guys? Thanks. Okay, does anybody have questions? Yeah, they will still stay in the video. That's correct. Yep. Yep. I can get the booklet back. Excuse me. Is it about a certain page that you want me to turn to, Renee? Does anybody have any questions? Oh, got it. Okay. Take care. I'll see you tomorrow. Bernoulli is not really linear just because it has like, we turn it into a linear. I'm just trying to flip back to show you. So this is once we get it to this, it's linear. But in the start, it's got that y of x squared, right? So if it didn't have that, it would be linear. But because it has this, then it's Bernoulli. So it's a specific type that's not really linear. But because of our substitution, we got to make it into a linear. So that's, kind of partway down, that's where we turn it into a linear with a substitution. Yeah. Okay, other questions?